Good morning everyone. Today we are going to see the system requirement specification, so commonly called as SRS. The SRS is one of the most important documents in software development because it clearly describes what the software system should do. It is usually written in simple natural language so that both customers and developers can understand it easily. The SRS acts like a contract between the customer and the development team. Before coding starts, both sides should agree on this document. Large software companies also use specialized requirement management tools such as IBM Relational Request Pro and DOORS to create, manage, and track software requirements. So next one is requirements elicitation. So after gathering requirements from the customer, we cannot directly write them into the SRS. So we first analyze them using three important filters. First one is deletion, second one is distortion, third one is generalization. So in deletion, where necessary or incomplete information is stored; distortion, where we verify whether the information is accurate or whether the customer has made assumptions. Third one is generalization. Here we identify general rules or policies from the collected information. These filters help developers to prepare a complete, clear, and accurate software requirement specification. So let's understand the deletion filter using a library management system example. Suppose the customer says they use the system to borrow books. Here the word "they" is not clear. So the analyst asks who exactly uses the system. Do all users borrow books? After discussion, we understand that only borrowers use the borrowing feature, while librarian may use the system for stock management. This process removes ambiguity and makes the requirement more specific. So now let's see the distortion filter. The customer says borrowers cannot borrow another book until all overdue books are written. The analyst asks another question: is there any exception to this rule? The customer explains that if a last book has been paid for, the borrower is allowed to borrow books again. This discussion helps correct assumptions and ensure the requirement accurately reflects the organization's actual policy. Next is the generalization filter. Suppose the customer says everyone must have a library ticket to borrow books. The analyst asks, does this rule apply to every user? The customer explains that other libraries or special members may have different types of memberships or borrowing privileges. This helps identify exceptions and develop more flexible software that can handle different categories of users. So the challenge is there any users of the system who might not need to have a ticket? The response is some users of the system, such as other libraries, may not need a ticket or may have a special type of ticket with different terms and conditions. So from these examples, we understand that the requirements elicitation is not just about listening to the customer. Developers should ask questions, clarify the doubts, identify the exceptions, and confirm every requirement. Good communication between the customer and the development team helps avoid misunderstandings and reduces software defects. So remember, asking more questions during the requirement phase saves a lot of time during development. So requirements tells us what the software should do, not how it should be developed. Requirement engineering helps collect, analyze documents, and validate customer needs. So it can be functional or non-functional requirements. So finally, requirement elicitation uses three filters: deletion, distortion, and generalization to make the requirements clear, complete, and accurate. These concepts form the foundation for successful software development. So now we have reached the end of today's topics. Today we learned about the system requirement specification, requirement elicitation, and the three important filters used while collecting the requirements. So always remember that a software project becomes successful only when the requirements are clearly understood before development begins. In the next class, we will continue with the next topic in object-oriented software engineering. Thank you everyone. If you have any Any questions, I will happy to answer them. Thank you.